Well, thank you, ladies and gentlemen, for being here today and not leaving your seat when I got introduced. That's a bonus. However, I did notice that everyone seemed to have a very good lunch. Is that right? Yeah. So, because you all had a very good lunch, there is a walking component of my session. So we're going to talk a little bit, then we're going to go outside and have a look at the actual antenna, which Jan has already set up for us in the backyard. So I'm sure by these days everyone's probably much heard of the T2FD. No. Okay, so if you haven't heard of it, here it is. So we've got a bit of a diagram there. This is a typical one here. So there's a feed point, usually a balun, sometimes 4 to 1, 9 to 1, however you want to make it work, and a terminating resistor and a length of wire on each leg. So it's like looks like a folded dipole with the opposing centre terminated. Theoretically, in the characteristic impedance of your balun, but does it always work? This is still room for experimentation here. So what does it do? It's a balanced terminated folded dipole. Amateur station W3HH was one of the developers, and it was developed by the United States Navy during the Second World War. Amazing how in wartime we all go and invent a whole lot of things. Okay, the reason to have a broadband antenna that didn't have to be retuned if possible. So it performs reasonably well over a broad frequency range. The downfall is it can be inferior in its efficiency due to the terminating resistor. Up to at least 30% of the RF power ends up in the resistor. It's good if you want a broad antenna for a system such as automatic link establishment, such as using a lot of commercial service and that kind of thing now, where you just press the button and the radio will start firing off cell calls on different frequencies until it talks to the other end on the best signal strength, and then I can say, oh yes, we've got the other end, here it is. And in fact, through WISEM we actually did some experimentation for a government group who hitherto were relying on mobile phones for emergency communications, particularly in power blackouts. So one of the people on this program was a ham, and he said, Mal, we know that it works, but just prove it. So he did some experiment. On a particular day, we recorded talking all over Australia on HF, and we're able to just bring back an actual thing and say, yes, we did that, it's provable. And this particular government department is now putting in multiple stations, I think 8 frequencies per end with automatic link establishment. So they can just press a button and it will find the right HF frequency, no need to call on different frequencies, just press the cell call and away it goes. So the antenna doesn't, if it works correctly, doesn't need tuning. And works well in digital modes. It just works on a frequency, doesn't care what it's being modulated with. And this particular antenna we'll talk about now is good for NVIS. And why would we want NVIS communications? We've talked about contesting today, which is a great thing. We talk overseas and all that kind of stuff. And if you think about my background, tell me, why do you think we might need NVIS communications?
Local.
Local to near or to semi-distant stations.
In mountainous territory.
Say typically up and down the east coast, and maybe if you can get the frequency and time of day right, maybe over to the west coast.
In the 94 bushfires from the waterfall scout camp at the bottom of the valley to Ingadine High School.
And that gives a real hold out of waterfall.
Absolutely. So it goes without saying, I'm sure just about every amateur radio operator knows the story, but HF still has its use. The military kind of went away from HF for a while. Still had it, but it wasn't a big part of their portfolio, and they're now giving it much more credence. The ability to use digital voice over HF and much faster message passing, digital message passing. So the military's got a great interest back in HF. But one of the reasons is that it doesn't go via a satellite, which someone else can pop out of the sky at the wrong time, which they worked out again. Even though I think everyone had that idea, they kind of started working it out, that the satellite may not be there. Something about GPS reliability? Anyway. So in the past, you'll see them at coast stations where they change on different frequency bands, SES, outposts, embassies, The police used to use a lot of C2FDs and so on. So for if you like, a one-size-fits-all antenna, and of course we know there's always a problem with one-size-fits-all, but something that will generally work can be constructed, no special skills needed to build it. You build it out of the packet the manufacturer sends to you and off you go. So here's a typical plot, SWR plot going from around 1 megahertz right through to about 30 megahertz. Okay, so we're going to actually show you in live time the plot on our antenna out in the field today. So they're not perfect, they're not flat across the band, and the flatter it is, what do you reckon is more likely in their secret little box? A resistor. See the typical design there?
Can I ask a question?
Sure.
Resistor, what rating would it be? I mean,
It's around about typically 50% of the expected power from the radio.
how much resistance?
Typically, but not always, it's the same impedance as if, say, you've got a 4-to-1 balance, so 300 ohms, so you put a 300 ohms. Quite a few years ago, actually, I built one when I was working actually at 2FC at Liverpool, actually, to also get broadcast band filters for the HF radio. 50 kilowatts straight into the radio. Not a good thing. And we actually worked out, even though it was a 300 ohm feed, we were better off using 200 ohms. We got a flatter result. So it's a bit of experimentation. What length of, how much wire you're using. There's different lengths. You can see this pops up all over the internet. Today we're using an antenna with basically 2 loops of 25 metres each. So strung out closely together, it's about 12, 13 metres on each leg.
Now,
Yep.
I have Bushcom dipole at home.
Yep.
And it's about 1 to 1.5 S points lower than Bushcom.
Yep.
In side-by-side tests.
So as I said, they're not perfect. They're a compromise. But if you want something you can put up in a hurry without too much mucking around and get it working, there it is. This particular type uses 3 wires, probably a bit more bandwidth, flatter bandwidth. Never actually played with that type.
Also higher impedance.
You can mount them in a sloping arrangement. You can also go for a flat arrangement. You can go for an inverted V arrangement. And here's an inverted V arrangement here. So the one we're talking about today is the butterfly antenna, mainly because it looks a bit like a butterfly, okay? So you would have heard, who's built a butterfly antenna for Wi-Fi? Somewhat higher frequency band. Okay, one lucky person. So typically a bow tie antenna, that's another name. So a few names slung around. We'll show you our actual antenna when we go outside. It looks a little bit like this one. How did we come up with the dimensions? Remember we said that Jan likes working out what's in the box and how it works? We pulled a commercial one apart. Because we really want to know, right? You buy these like commercial broadband antennas and the Bushcom's a straight dipole with a little black box, a certain way down each leg. But you don't know what's in it. And of course, if you want the best SWR, what kind of antenna do you use? A 50 ohm resistor. Works every time. So you really don't know what they put in these little boxes. Anyway, so we actually got a broken commercial model and pulled it apart and we came up with the dimensions that we're using today. What else can you do with it? Here we go. Use it to put the fire up the side of your house here. Another example of people that have used this antenna for. This is where we get the sort of typical name from it, the broadband butterfly antenna. Ours doesn't look like quite as much as a butterfly, but a bit of artistic license. Ours looks a little more like this one. So the centre support, thankfully provided today by AR New South Wales tree, in exactly the right place. It cut down about 15 minutes of antenna pole, so good thing. And essentially fed in an inverted V fashion down to the ground. And it's a minimum of construction. All you need is a pole, an antenna. Most of us have some sort of, and the typical height is 5 or 6 metres. So you can get it to work for that. Remember, we're not going after a DX antenna, we're going after NVIS, so we can use it reasonably low to the ground. And we actually have the flat ends of the antennas actually running on the ground. So very straightforward. All you need is one centre support, tree, pole, whatever. the appropriate length of wire, which is like 50 metres overall, 2 loops of 25 metres, and took us about 10 minutes to just set it up. And a little bit of that time was because we picked the wrong limb on the tree. We had to relocate it, so a bit of error. So we have here a direct facsimile of the one we're going to have outside. So you can see the wire all wound up there, the actual terminating resistor and the toroid in the box here, and how small the package is that you can put it in basically a shaving bag. I'll start passing that around if you'd like to do that for me. So there'll be no exam questions, it's okay, you don't need to check on the values. It just gives you an idea of how the transformer works or configured. And there you go, there's our center unit up in the tree. So we'll take that with us and we can still pass it around outside, and we'll go for our post-lunch digestive walk. How does that sound? So out through that door fence and then over that way to the rear of the shed. Okay, here we are again. Thank you very much for travelling that huge distance out. So here we have the antenna set up. The footprint, obviously with the slope, is about 10 metres or 9 to 10 metres either side of the centre support. And we don't have to use any spreaders, fiberglass spreaders or wooden spreaders or anything like that. You'll see if you research the VK2FEB spreading the wires apart and that kind of thing. So it makes it small, easy to set up and not heavy and not trying to sort out bits of wires and spreaders everywhere. So standard 50 ohm coaxial feed, center point here, and the two ends there. And if you can see, or can't quite see because we're using that flat wire, that the two ends are about 1 metre apart. So we have played around with that meter, bringing it in and out to see if it will change the frequency response and so on. And yes, it does a bit. And you might find when you set yours up, if you make it, that something better, different to this will work for you, as always. It's just another, and as I said, it's not a perfect antenna. There is that implied inefficiency, firstly using a ballon and then with a resistor, but it's an antenna that will generally work all the time. So Jan's got it set up over here. Yep, the computer doing the VSWR plot. So it might take a little while to file pass, and you'll see, and this unfortunate artifact, it doesn't look so good on 40 metres. The SWR is 4:1, as you can easily put that on the tuner. Well, it is an old design, back 1940s. And it's like everyone thinks NVIS was only invented a few years ago, but in fact, no, they were experimenting. They coined the term NVIS in the 1940s.
It works, it works. As he says, the best part is that you don't have to tune it. It's, well, sort of.
How many of you have receiving up
The
there?
first time I saw it, I said, I don't. We tried it and it
You
works.
see the good of all worlds.
Put the center, you got to keep that rough same angle.
The thing is very high, static electricity is very low. Yeah. And yeah, that are the two things
The yarn
like the light for the ceiling. And goes over the whole bed.
So how are we going, folks? Is there anything else you want to see or know about this antenna?
Will it change polarity by twisting the legs from horizontal?
Don't know. Haven't tried it. I just tried to replicate what came in the user manual for this commercial antenna that we reverse engineered. It's a good question though, and quite seriously, I don't reckon it's the best.
Yeah.
And it could be optimised, and we keep saying that, but that's been used a few times today. But we're now going to experiment with it a bit more, and like taking the ends off the ground, and we're going to add a bit more wire to the loop and actually change things around.
I'm just wondering if you cared about 40 fiddles, you might
You might
get down and have a top up somewhere else.
Exactly. We're going to give that a try.
Yeah, that'd be well worth doing.
Yeah. Although,
Because 40 would be exactly what you wanted to use for a guy.
however, being a proponent of auto tuners, I don't tend to worry about. But
Sometimes it's good to just buy a little QRP radio and it's not.
to be honest, absolutely, and I thoroughly agree, and that's why we want to
you make it right. Yeah.
make it right. So it works because we reckon we've fiddled around and moved lengths and sizes and seen different things change, and we're going to also look again at the terminating resistance value and change things around to see if we can actually get 40 metres back, because I happen to like 40 metres. So.
Yeah.
But do you think that it depends on the wire length for 40 metres? Like, I mean, it looks like a bit around dipole.
It is very much a fine. It's it is, exactly.
So,
Yeah.
if you've got that length like for 40.
That might be the limiting factor. 40 and 80 metres is fine, and even down to nearly the 150 as well. So a bit of impedance transformation where it's actually one part of the match right, but the rest of the circuit is no, so it's providing that it's not working 40 metres. I mean, you can't say it doesn't work. It does work. With a tuner, we've operated on 40 quite successfully. Yeah. But even on voice, you just go there. Basically, a length of wire and a tuner, off we go.
Yeah.
That's the well, of all these broadband antenna concepts, this is which this is one. That's the idea of, for commercial purposes, particularly or emergency services, that they can use ALE quite easily without having to worry about even auto tuners and that kind of thing. So, how's everyone going? Have we seen enough? Are we good to finish, or we'll head on back inside? Thank you, everyone.